Imagine a murder weapon so perfect that it flawlessly mimics a natural, devastating bacterial outbreak.
Right, something that completely tricks the smartest doctors into just signing off on a natural death.
Exactly. But at the exact same time, this weapon is so fundamentally flawed that it acts as this indestructible black box.
Just preserving the undeniable evidence of the crime deep inside the victim's bones for decades.
It is wild. So welcome to today's deep dive. Our mission for you today is exploring a fascinating, honestly chilling set of medical jurisprudence and forensic toxicology notes.
And these notes are focused entirely on one of history's most notorious substances, arsenic.
Yeah, and our goal today isn't just to, list off medical symptoms. We really want to help you understand how this element became the ideal homicidal weapon.
While also serving as the ultimate trap that catches the killer.
Okay, let's unpack this. Because it is wild to me that something completely natural, literally pulled straight from the earth, can be so profoundly deceptive.
It truly is a masterclass in chemical deception. But to understand the mechanics of that deception, we have to establish what arsenic actually is in its natural state.
Right.
If you were to find pure arsenic in the earth, it presents as this gray, metallic-looking substance. And here's the first surprising fact that catches most people off guard.
Okay.
In that pure gray form, it is practically non-poisonous.
Wait, I need to stop you right there. Pure arsenic is safe.
I know, right?
That feels like it goes against literally everything we've ever been taught about toxicology.
It really does seem counterintuitive, but it essentially comes down to solubility. Pure gray arsenic is entirely insoluble in water.
Oh, meaning it won't dissolve.
Exactly. Because it won't dissolve, your alimentary canal, your digestive tract, simply cannot absorb it into your bloodstream.
So if you ingested it, it would just
pass right through your system, yeah, completely harmlessly.
That is bizarre.
But the danger lies entirely in its chemical instability. Once it's exposed to air, it is continuously oxidizing. It changes its chemical structure into arsenious oxide.
Which is universally known as white arsenic, right?
Correct. Or, in some local regions, the historical notes refer to it as sankhya or sumakar. And the moment it makes that transition into white arsenic, it crosses the threshold.
Right.
It becomes a tasteless, odorless, and just highly lethal killer.
It's like a sleeper agent.
Yeah.
It just sits there completely benign until it interacts with oxygen, changes its form, and then boom, suddenly you have a lethal weapon.
Exactly.
So we know what it is physically, but let's look at why it was used so frequently. Reading through these sources, I kept visualizing white arsenic as like a microscopic stealth bomber.
That is a highly accurate way to frame it, especially when you look at how it behaves in a domestic setting.
Because physically, it behaves in ways that just seem to defy common sense. Like, the notes describe white arsenic as a heavy powder.
Yeah.
And you would think a heavy powder would just sink like a stone. But paradoxically, if you drop it in a glass of clear water, it floats on the surface.
It does. And worse, it adheres. It physically sticks to the sides of the glass vessel.
Which is such a giveaway. So historical poisoners ingeniously realized very quickly that they couldn't just drop it in a glass of water.
Right. The victim would raise the glass, see this strange white powder clinging to the edges, and just stop drinking.
Exactly. Instead, they had to hide it in thick, opaque liquids. Milk, tea, coffee. A murderer's best friend was a dark, heavy beverage.
Which completely bypass the victim's senses. I mean, there is no bitter almond smell like you have with cyanide. There is no metallic tang. It's completely hidden.
If you're holding a cup of morning coffee right now as you listen to this, just look at it for a second. Imagine someone slipping a heavy white powder into it and you taking a sip, completely unaware.
It's terrifying.
It really is. So if this stuff is invisible to our senses, how exactly does the body react when it's ambushed like this?
Well, the mechanics of acute poisoning are brutal, and they happen at a microscopic level. When that white arsenic enters the system and gets absorbed, it goes straight for the cellular machinery.
Okay.
Specifically, it targets and combines with sulfhydryl enzymes.
Wait, I want to make sure we don't lose anyone in the medical terminology here. What exactly is a sulfhydryl enzyme?
Sure.
And why is it so catastrophic if arsenic targets it?
Think of sulfhydryl enzymes as the spark plugs of your cells. They contain sulfur, and your cells rely on that sulfur to transfer energy and essentially breathe.
Okay, that makes sense.
Now, arsenic has an incredibly strong chemical affinity for sulfur, so the arsenic rushes in and binds tightly to those sulfur groups.
It just latches on.
Yeah.
Yeah.
If we use a physical analogy, it's like someone pouring super glue into the ignition lock of a car.
Oh, wow.
The key won't turn anymore, the enzymes are locked up, the cells can no longer process energy, and cellular metabolism suffocates.
And it doesn't take much of this super glue to shut the whole engine down, does it?
Shockingly little. The notes state that a fatal dose of white arsenic for a full-grown adult is just 120 to 200 milligrams.
It's just tiny.
To put that in a visual perspective for you, 200 milligrams is roughly the size of a single match head.
Wow. One match head of this stealth bomber powder in your tea.
Yeah.
How fast does the ambush actually happen once you swallow it?
In acute cases, meaning a single massive dose, the symptoms usually manifest within 15 to 30 minutes, though a heavy meal can delay the onset slightly.
Okay, and what does that look like?
It begins with an intense burning pain in the esophagus and stomach
Hmm.
that is quickly followed by severe, persistent vomiting.
Oh.
And the vomit changes as the body panics. It starts as stomach contents, then bile, and eventually thick mucus mixed with altered blood.
That sounds horrific.
But the main effect, the one that made it such a perfect weapon historically, is the profound intestinal purging.
Oh, right. The notes refer to this specific symptom as rice water stools.
Mhm.
What does that mean exactly?
It describes severely watery stools that contain actual shreds of the intestinal mucous membrane. The arsenic is literally destroying the lining of the gut.
That is grueling.
And here is why that specific gruesome detail matters so much to the history of murder. That exact presentation, the severe dehydration, the agonizing cramps, the rice water stools, perfectly mimics the exact symptoms of cholera.
That is just terrifying. I mean, if you think about the world before modern medical diagnostics, when bacterial outbreaks were a regular, devastating part of life,
Oh, absolutely.
a sudden violent illness that looks exactly like a natural cholera outbreak, it provided the absolute perfect cover story for a murderer.
A local doctor would walk into the bedroom, see the profound dehydration, the cold, clammy skin, the sunken eyes, which are all signs of massive vascular collapse caused by the arsenic,
Right.
and they would simply write cholera on the death certificate. The victim would typically die in 12 to 48 hours in this gastrointestinal form.
Just incredibly fast.
Yeah. There's also a narcotic form where the dose is so massive it skips the stomach symptoms entirely and goes straight to central nervous system collapse, killing the victim in as little as 2 to 3 hours.
It really makes you realize how vulnerable people were to these supposed sudden illnesses.
Yeah.
Like, if you had a bitter enemy or a greedy relative waiting on an inheritance, a cup of tea could just be the end of you, and society wouldn't blink an eye.
Not at all.
But that is just the acute attack, the sudden overwhelming strike. What if the killer is patient?
Oh, yes.
If acute poisoning mimics a deadly cholera outbreak, how does chronic long-term poisoning hide? Because I have to admit, I was completely thrown when I read the source notes on this.
How so?
Well, I saw the description for the second stage of chronic poisoning, and it says it feels like a common cold. Conjunctivitis,
Yeah.
a cough.
Yep.
How could anyone, a highly trained doctor or the victim themselves, possibly know they're being systematically murdered and not just catching a winter bug?
What's fascinating here is how methodically arsenic dismantles the human body over time when introduced slowly. Chronic poisoning usually occurs when a victim is given repeated, small, sublethal doses, or when they are exposed environmentally over months or years. And your confusion is entirely justified. The misdirection is incredible.
Right.
The notes break chronic poisoning down into 4 devious stages.
I really want to walk through these because it is essentially a masterclass in biological disguise.
Okay, so stage 1 is categorized by nutritional and gastrointestinal disturbances. The victim experiences gradual emaciation, a profound loss of appetite.
Just general wasting away.
Exactly. Plus intermittent, unexplained vomiting. If you take those symptoms to a doctor, they're very easily misdiagnosed as a simple, stubborn stomach bug or just general fatigue and malaise.
All right, there's absolutely nothing screaming foul play yet.
Then the poison pushes into stage 2, the catarrhal changes. This is the common cold phase that shocked you.
Yes.
The mucous membranes throughout the body become deeply inflamed. The victim develops running, red eyes, a runny nose, a sudden hoarseness of voice, and a persistent bronchial cough.
So now the victim just thinks they've caught the flu, and they're probably drinking more hot tea, which might be exactly how the killer is delivering the next dose.
It's a vicious cycle. It is only when we reach stage 3 that the truly bizarre, unmistakable signs begin to appear on the outside of the body. The skin rashes.
What kind of rashes?
Well, a victim might experience intense irritation or a nettle rash. But the absolute telltale signs are these patchy brown pigmentations that develop on the skin. The forensic notes refer to this as a raindrop-type pigmentation.
And even with those spots, the text says this was still frequently misdiagnosed as Addison's disease. I had to look that up.
Oh, did you?
Yeah. Addison's is a real disorder where your adrenal glands don't produce enough hormones. And one of the main symptoms is hyperpigmentation, your skin darkening. It's
Right.
like the poison is actively throwing up false medical flags to confuse the doctors.
It literally provides its own alibi. During this third stage, you also see hyperkeratosis, which is a severe thickening of the skin on the palms of the hands and the soles of the feet. Yeah. And the victim's hair starts falling out in clumps. Their nails become brittle. And this is where forensic toxicologists look for something called Mies lines.
Oh, I saw that in the notes.
These are distinct horizontal white bands that cross the fingernails and toenails.
I love the analogy I was thinking of for this. It's exactly like counting the rings on a tree, but for toxic exposure.
That's a brilliant way to visualize it.
Mm.
As the nail grows, the white band literally indicates the specific period of time where normal metabolic cellular growth was arrested by the presence of the poison.
Wow.
It is a physical timeline of the poisoning etched right into the body's keratin. And finally, if the victim somehow survives to stage 4, they experience severe nervous disturbances.
Like what?
Tingling and numbness in the hands and feet, extreme tenderness of the muscles. This arsenical neuritis so closely resembles the nerve damage seen in late-stage alcoholism that, once again, the poison provides a cover story.
Unbelievable.
Friends might just assume the victim developed a secret drinking problem to cope with their prolonged illness.
The psychological torture of that is staggering. You're dying, and everyone thinks you're just a sick alcoholic. But before we talk about how investigators catch these killers, there was a detail in the notes that completely derailed me.
Let me guess.
It mentions that some people actually subjected themselves to this horror on purpose.
Ah, yes. The arsenophagists. Throughout history, particularly in regions like the Austrian Alps, there were individuals who intentionally consumed arsenic.
Why on earth would they do that?
They firmly believed it acted as a health tonic, a cosmetic skin enhancer, or even an aphrodisiac. They would start with tiny flakes and actively build up a biological tolerance.
A tolerance to arsenic.
Yeah. Some documented individuals could consume up to 250 milligrams in a single sitting, which we established earlier is well over the normal fatal limit for an adult.
That is insane.
But biology always wins. They couldn't outrun the chemistry forever. The practice inevitably led to the exact same horrific stages of chronic poisoning we just discussed.
Okay, so let's say someone is caught in this slow burn trap, whether by murder or their own foolishness. They have the Mies lines, the raindrop pigmentation. A sharp doctor finally figures out it isn't cholera, it isn't Addison's, and it isn't a cold.
Right.
I was intensely curious about the medical intervention. The notes highlight a specific treatment, an intramuscular injection called demercaprol or BAL.
Yes, BAL.
I tried to picture how this works, and if I'm understanding the chemistry, BAL acts almost like a chemical bouncer inside the body.
A chemical bouncer. That's fantastic. Let's explore the mechanics of how that bouncer clears the room.
Well, I need your help with the exact science. The text says BAL has 2 SH radicals, and it goes into the tissue, grabs the arsenic, and dislodges it. How exactly does it rip the poison off the victim's cells?
It comes down to chemical affinity and the SH radicals, which are those sulfur groups we talked about earlier. Remember how we said arsenic loves the sulfur in your body's enzyme?
Yeah, the superglue in the ignition.
Well, your natural enzymes usually only have one sulfur group available to grab. BAL, or demercaprol, is a synthetic molecule designed specifically to have 2 sulfur groups sitting right next to each other.
Oh, I see where this is going.
Arsenic vastly prefers to bind with 2 sulfurs rather than 1. So when you inject BAL into the victim, the arsenic literally lets go of the victim's cells because it gets drawn to the stronger magnetic pull of the medicine.
So it willingly detaches from the cellular ignition switch to grab the medicine instead.
Precisely. The BAL forms a new, stable, completely non-toxic complex with the arsenic, and the body's natural filtration system physically escorts that trapped complex out of the body through the kidneys and the urine.
Wow.
It reverses the inhibition of tissue oxidation. It gives the suffocating cells their breath back. Between rapidly washing the stomach, administering hydrated ferric oxide to neutralize the poison in the gut, and using BAL to bounce the absorbed arsenic out of the deep tissues, modern medicine finally has a fighting chance.
Which is incredible. We've seen exactly why arsenic is this stealth bomber, this historically ideal weapon. But here's where it gets really interesting. This is the ultimate pivot of our deep dive.
Okay.
Because as much as arsenic is a flawless weapon in the heat of the moment, it is fundamentally a terrible choice for a murderer who wants to get away with the crime forever.
It truly is. It sets the ultimate trap for the killer.
I look at it as a biological black box recorder for the human body. You know how when an airplane tragically crashes, the black box is engineered to survive the fire and the incredible impact to tell investigators exactly what went wrong?
Right.
Arsenic does that exact same thing to the victim's corpse.
If we connect this to the bigger picture of forensic pathology, arsenic has several fatal flaws from the poisoner's perspective. First, and perhaps most ironically for someone trying to hide a murder, it actively retards putrefaction.
It literally embalms the victim from the inside out.
Yes. The body remains exceptionally well preserved. So if rumors start swirling and a suspicious death leads to a magistrate ordering an exhumation months or even years later, the soft tissue evidence hasn't decayed.
It's just sitting there.
It is sitting right there waiting for the chemical examiner. Second, arsenic is an elemental metal. It simply does not deteriorate over time.
And it survives extreme heat. There is a case study in the notes from 1948 in Uttar Pradesh that reads like a thriller.
The daughter-in-law case.
Yes, this chilling story involves a man who had an illegal connection with his daughter-in-law. To get rid of her, he poisoned her with arsenic. Knowing he needed to hide the evidence, he quickly threw her body onto a funeral pyre and burned her to ash.
A classic attempt to destroy evidence.
But local police were tipped off. They arrived, collected the charred bones and the ashes from the pyre, and sent them to the lab. The chemical examiner found the arsenic right there in the ashes. The fire couldn't even erase it.
Because it is a fundamental element on the periodic table. You cannot burn an element out of existence. And remember those Mies lines we talked about on the fingernails?
Right, the tree rings.
Arsenic deposits permanently in keratin tissues, the hair, the nails, the skin scales. It also deposits heavily at the ends of long bones, like the femur. It creates a permanent physical ledger of the crime.
Like the Badal case mentioned in the text, this was a young daughter-in-law whose husband and mother-in-law conspired with a local doctor to slowly poison her over 3 agonizing months.
Over a car, right.
Yes. The motive was just greed. She hadn't brought enough dowry for them to buy a car. They took her to Delhi. She was practically dying, but the authorities caught up with them.
And how did they prove the slow 3-month poisoning?
Because the chemical examiner found sufficient arsenic trapped in her hair, her fingernails, and even the dry scales scraped from the soles of her feet.
Incredible.
The very body they were destroying became the star witness that convicted them.
The science of detection simply caught up to the chemistry of the poison. Even the mundane items used to administer the poison become permanent witnesses.
Like the food.
Exactly. Look at the 1923 case of Azamula. A 70-year-old man is poisoned with a simple meal of bread and potato curry. He suffers the classic horrific symptoms, the burning throat, the vomiting, the purging, and dies the very next morning.
Okay.
When the authorities investigated, the chemical examiner didn't just find arsenic in his stomach and liver. They tested the leftover food and found the white powder baked directly into the dough of the bread itself.
The black box recorder. It just preserves the truth in the bread and the bones and the ashes. But this brings up a massive, unsettling question.
Okay, what is it?
We've been talking entirely about malicious intent so far. Murder, greed, betrayal. But if arsenic is this indestructible element and it naturally exists in the DNA of the earth, what happens when it's not murder? What happens when it's just a tragic environmental mistake? So what does this all mean for the justice system? If the black box never vanishes, how do forensic scientists know if someone was actually murdered, or if the earth itself is just framing them?
This raises an incredibly important question, and it's a phenomenon that modern forensic pathologists have to be acutely paranoidly aware of. The scientific term for this is post-mortem imbibition.
Post-mortem imbibition. Imbibing after death.
Precisely. Let's visualize a scenario. A dead body is buried in a wooden coffin in soil that happens to contain naturally high levels of arsenic.
Oh.
Or perhaps it's a graveyard located downhill from a farm that used heavy arsenical weed killers, and the groundwater carries it. Over years, as the coffin degrades, that environmental arsenic dissolved in the groundwater can physically seep into the corpse.
Oh, that is terrifying. So an investigator digs up a body, tests the liver, gets a positive hit from massive amounts of arsenic, and immediately assumes a husband murdered his wife.
When in reality, the body just absorbed it from the dirt like a sponge.
That is exactly the danger.
That is why modern forensic protocols rigidly dictate that if you suspect arsenic poisoning and you exhume a body, You must take control samples of the earth from all sides of the grave, above and below the coffin.
You have to rule out the dirt.
You have to definitively prove in a lab that the concentration of arsenic locked inside the organs is significantly higher than the concentration in the surrounding soil.
Which makes that historical story about the London husband in the notes so deeply haunting.
It is perhaps the greatest cautionary tale in forensic toxicology. This man lived in London, and his numerous wealthy wives all died, one after the other, under what appeared to be highly suspicious circumstances.
It doesn't look good for him.
No, it doesn't. Scotland Yard gets involved. They exhume the bodies from the local cemetery, they run the tests, and they find high levels of arsenic in the remains.
So the police are certain they have a serial poisoner on their hands.
The man is tried, convicted, and sent to the gallows, proclaiming his absolute innocence to the very end.
And then, years later, the black box reveals a different story.
Years later, a curious toxicology student decides to revisit the case and goes out to test the soil of that specific London cemetery where these wives were buried. And they discover the soil itself was naturally saturated with arsenic.
Wow.
The poison could very well have seeped into the coffins via post-mortem imbibition.
Meaning, Scotland Yard might have confidently hanged an entirely innocent man. The student wondered if they were ever really poisoned at all, but by then, the man was dead. That is the dark side of the black box. If you don't read the data correctly, you just create a brand new tragedy.
Exactly.
And the danger wasn't just lurking in graveyards. The notes detail how every day domestic items used to be absolutely dripping with this stuff.
During the 19th and early 20th centuries, industrial and agricultural uses of arsenic were shockingly widespread, with almost zero regulation. Arsenate of lead was sprayed everywhere as a fungicide. Arsenites of sodium and potassium were the main ingredients in commercial weed killers and agricultural sheep dip.
The text even mentions the copper compounds of arsenic, things like Scheele's green or Paris green.
Oh,
Yeah, these were brilliant green pigments used to color artificial flowers, children's wooden toys, and domestic wallpapers. You could literally be wrapping your child's nursery in a toxic, cell-suffocating blanket, and the microscopic dust would just flake off into the air they breathe.
the absolute lack of respect for the chemical led to catastrophic, large-scale accidents. The most harrowing example provided in the forensic notes took place in France in 1952.
The Beaumont case.
Yes. A 59-year-old chemist named Jacques Cazeneuve manufactured a very popular talcum powder called Beaumont specifically for babies. But during production, he made a catastrophic supply error. He accidentally replaced soothing zinc dioxide with pure white arsenic.
And people dusted their infants with it. An absolute epidemic of horrific sores and severe chemical burns broke out among the children.
Yes, 73 children died from the exposure. Another 270 were severely injured and permanently scarred. Not out of malice, not for inheritance or dowry, but through a simple, catastrophic chemical mix-up in a factory.
It's just devastating.
It highlights how profoundly dangerous it is to have an invisible, tasteless, odorless poison so deeply integrated into everyday commerce.
The scale of that tragedy is just staggering. When we step back and look at the incredible journey we've taken today, we started with this invisible, heavy powder, something so perfectly suited to hide in a dark cup of coffee and mimic a natural cholera outbreak.
A true stealth bomber of the biological world.
And yet, the very properties that made it so deadly, its elemental permanence, its affinity for sulfur and keratin, turned it into an indestructible black box recorder. It outlasts the flames of a funeral pyre, it hides patiently in the dried scales of a victim's foot, and it exposes greedy murderers years after they thought they were safe.
If we synthesize all of this historical and scientific data, arsenic today is largely a historical poison in terms of both therapeutics and homicide. But studying these old forensic notes forces us to appreciate two vital things.
What are those?
First, the incredible, hard-won evolution of forensic science. Moving from a world where doctors could easily misdiagnose a cold or Addison's disease to a world where we can find microscopic traces in ashes and differentiate it from the graveyard dirt.
Right.
And second, it heavily deepens our understanding of cellular metabolism, showing us exactly how fragile our internal biological engine is when someone pours superglue into the ignition.
It really does. It shows us how far we've come in understanding and protecting ourselves from the Earth's natural traps. But it also leaves me with a lingering thought that I want you, our listener, to ponder as we wrap up today's deep dive.
Go for it.
We have conquered the white powder of the past. We know how to find arsenic. But in our modern world, we are surrounded by thousands of brand new synthetic chemicals. We are breathing in industrial exhaust. We are ingesting microplastics in our food and water daily.
We really are.
So here's the question. Are there new arsenics out there right now? Invisible stealth bombers currently accumulating in our cells, mimicking everyday modern ailments like chronic fatigue, mysterious inflammation, or lingering common cold, that our modern medical diagnostic machines simply haven't learned how to detect yet.
That is a chilling thought, but an absolutely essential one for the future of modern toxicology. We must always question what is hiding in plain sight.
Until we find out, keep an eye on your coffee.